Hello and welcome to On the Ledge podcast, the podcast for people who love their plants. This week's show is dedicated to the topic of, brace yourselves, thrips. Yes, that pest which we've all come to fear comes under the beady eye of On the Ledge this week, so get your hand lenses at the ready. This one is not for the faint-hearted. Plus, I answer a question about whether a plant can recover from cat-related damage. Oh dear, Pussy's got her claws out.
Hello, I'm William Kirk. I'm a Professor of Applied Entomology at Keele University in the UK, and I've been studying the biology of thrips for exactly 40 years this year.
Now, there is no such thing as a thrip.
That's right. You'll see lots of people mentioning it, but it's a sort of false assumption that the singular is thrip, whereas in fact it's from a Greek word which ends in the letter psi, which is a ps sound. So we're stuck, unfortunately, with the singular of thrips being thrips. So it does seem a bit strange when if you talk about one thrips or a thrips. I've seen a thrips, but that is strictly correct.
Yeah, it's a bit like data, isn't it? I think that's another word that that scientists always have to struggle with. I think that this is going to probably trip me up, so I apologise in advance if I say thrip, but I'm going to try to say thrips throughout. Now, this is a pest of houseplants that is present everywhere in the world, as far as I know. Are we dealing with one species or lots of different species on our houseplants?
We're dealing with lots of species. In fact, in the world, there are known 6,000 species, although most of those just live in leaf litter on forest floors and don't really concern growers of plants. Then you get down to about 100 species that are pests of crops around the world. But on houseplants, you're probably talking only about 12, 14 species that are significant pests that people are likely to encounter. And of those, there are perhaps 2 or 3 that are the main pests because they feed on so many things. Some thrip species are very specific, will just feed on just a few species. And then there are other ones that feed on lots of different species. And you shouldn't take any notice of the name. When it has a name, something like onion thrips, well, okay, it's a pest on onions, but it's also a pest on lots of other things. So the names can be a bit misleading. But about a dozen species are the ones that you'd encounter on houseplants. And
presumably, this is another reason to be careful with, importing plants from other countries, because this is how they're spreading, coming in on plants and spreading to parts of the world that one species wasn't in before they've arrived.
That's right. We have quite a lot of invasive species of thrips. Something like, for example, the western flower thrips, which is perhaps one of the major thrips pests at the moment, was originally limited to just the western part of the USA. That's where the western came from. But since about the 1970s, it's spread worldwide. And once the insect, the thrips species, becomes kind of resistant to insecticides, then it's very difficult to stop it. And horticultural trade brings plants all around the world. So, you have cut flowers coming in from Colombia to the UK, then propagation material coming into the Amsterdam flower markets. And then the next day they can be in 400 garden centres all across the UK. So because the thrips are so small and easily overlooked, they get spread really frequently and easily by human trade.
Yeah, this is a big problem. And as you said, they are rather small and not the easiest thing to spot. I mean, I'm always going on about hand lenses on the show, but as soon as you get a hand lens on one and get some magnification, you start to see that there's probably more than you thought. What are they actually getting up to on our plants? And what are they doing in terms of damage?
They feed by piercing and sucking. So they have a mouth parts a bit like a drinking straw, but they poke into they pierce a hole in the cells in the plant or in pollen grains or cells on the leaves or cells in the flowers, pierce that and then suck out the contents. So you'll sometimes hear people saying that they rasp or scrape. That's not true. They actually pierce and suck. So by piercing and sucking, they suck out the contents. And that's how one of the common symptoms of thrips feeding is that you get this silvering pattern. So what's happened is that the pigmented the green chlorophyll or the pigment of the petal has been sucked out of cells, and you're left instead with a kind of empty cell full of air, and that gives that kind of reflective silvery look as a result of the feeding. So they move along, sucking out cells in turn and building up a sort of silvery area of the damage. So the main thing they do on the house plants, or on plants in general, is feeding. So the larvae, the young stages, are continually feeding. And then when they get to the adult stage, the adults are also feeding. So it's the feeding damage that's the real problem in house plants. Outside in crops, of course, thrips can also be vectors of plant viruses. And that can be very damaging in greenhouses or sometimes in outdoor crops. But I suppose in small collections of houseplants, you're probably not likely to have virus as a problem. It'll be the thrips that are doing the feeding that's causing the problem.
And we see one thrips on a leaf and think, oh, it's only one. But I imagine that they've got a life cycle that allows their populations to explode pretty fast.
Yes, that's one of the main features is how fast they breed. So if we start with the adults, you get males and females in most species. The males and females mate, and females lay eggs. The eggs are very small, about 1/3 of a millimetre, and are inserted into the plant tissue. So you can't see the eggs or find them except with very powerful microscopes. So we lay the eggs, those hatch quickly into larvae. You get 2 larval instars, and they're feeding on the plant. And then typically they drop to the ground for the pupal stage, which is usually on the surface of a soil or down the side of a flower pot. Sometimes they'll pupate on the plant in a little nook or cranny somewhere, not very obvious, but usually it's in the soil or on the surface of the soil. And then they will emerge and the adults will fly up onto the plant again. And that whole life cycle from egg to adult in a warm room, say 25 degrees, can take place in less than 2 weeks. And the females are laying eggs, a few eggs every day. They don't lay sort of batches of eggs like a butterfly, just steadily laying eggs throughout their lifetime as an adult, which might be 2, 3, 4 weeks. All that time they're producing the eggs, and every 2 weeks you've got those more adults coming through. So you could, from one adult coming in, one female coming in, you could have hundreds and hundreds within, say, 4 to 6 weeks.
It's interesting about the eggs being laid in the leaf material. Would that mean that if I was, say, wiping the leaves to remove an infestation with a damp cloth, that I wouldn't be wiping out the eggs because they just are lodged in the plant material?
That's right. They're nearly completely submerged. So wiping over the surface isn't going to do anything for the eggs. And that's also a problem, of course, with any kind of control measures. If you used any kind of insecticidal approach, the eggs are protected. They're within the tissue. So you might apply an insecticide of some kind and kill maybe adults and larvae, but you wouldn't get the eggs that are about to hatch, and you wouldn't get the pupae that are perhaps down in the soil. So that's why with an insecticidal approach, you'd have to repeat it at intervals so that you would then catch the ones that have been in the egg the first spray. By the time they've emerged, then you'd want the second spray because of all those protected stages. And it's not just that the egg and the pupa are rather can evade insecticide. The adults and larvae, a feature of them, they're not just small, but they tend to retreat into very small spaces. So they might retreat into leaf buds or flower buds or small spaces. And those small spaces are where insecticide often doesn't reach, or where predatory biocontrol agents might not be able to get into those small spaces. So they can evade all sorts of treatments, and the stages can protect them as well.
Wow, there is a challenging pest by the sound of it. Do you find that when you're dealing with commercial nurseries that this is a problem that is one of their worst glasshouse issues? I mean, is it sort of it seems worse than red spider mites in a way because of those factors you've just mentioned. Is it considered more serious to have a thrips infestation than, say, red spider mite?
Well, it changes over time. When you get these invasive species, which we've got several of them at the moment, sort of increasing, when they appear, then the growers have an enormous problem because they haven't sort of adapted or learned the best approaches for biocontrol, say. So when Western flower thrips arrived, say, in the UK in about 1986, it was an enormous problem, and the same in other countries when it arrived. One problem is that, say, in greenhouses, the growers in Europe certainly are now very much using biocontrol. Pesticides are very much not used, they've been very much reduced in the extent to which they're dependent on them. Biocontrol has taken over. But when you get a new pest that arrives and you don't have the biocontrol protocols and things worked out, the pest takes off, the thrips becomes a pest, and then you end up having to spray because you've got no choice at that stage. There's no alternative. But of course, when you spray, then that wipes out the biocontrol for all the other pests. And then you're in a sort of, the problem magnifies because then all the other pests, you lose their control of them. So when a pest first arrives, it becomes a big problem. But I think I'd say that now the Western flower thrips, certainly in Europe, there are well-established biocontrol protocols that keep the thing under control. But we've got another thrips that's just arriving in the UK called the Japanese flower thrips, Thrips cytosus. And again, that's something where people haven't really got the methods worked out, which are the best biocontrol agents and so on. So that is likely to become a problem over a few years, but then maybe that'll settle down as the biocontrol approaches are developed that are suitable for it. But I think I'd also add that thrips are generally seen as a bit of a nightmare for growers, both of protected crops under glass or plastic and outdoor crops. I've had pest advisors come up to me and say, I'm responsible for aphids and thrips for Northern Territories of Australia, something like that. And I'm okay with the aphids, but I really don't know what to do about the thrips because they're really very difficult to control. As I said, they escape treatments by being very small and hiding, but they also develop resistance to insecticides very rapidly. So we have a problem of, how on earth do you control them?
Wow, yes, this is obviously something that's going to be an ongoing issue in our globalized world. So we've talked a little bit about what signs we might be looking for in the plant. This silvering where they've I like the image of them sort of sucking up the plant cell material through a straw-like device. So the plant might be silvered. I mean, are you generally looking for a plant that's got that silvery effect, but also probably just looking generally miserable as it's kind of the life is literally drained out of it? Is there any other sign that they're going to leave? Like, I'm just thinking of the equivalent in red spider mites where you sort of see that white grainy stuff, which is their shed skins.
If you hang up a yellow sticky trap or a blue sticky trap, because the adults fly and are quite active, monitoring is one good way of picking up thrips infestations at an early stage. And of course, you might be using yellow traps for white flies or fungus gnats or shore flies or something else. And so they can be multi-purpose. So if you can recognize the thrips, then you might detect it at an early stage on a sticky trap. But on the plants themselves, of course, it depends a bit on the plant. There are some thrips that particularly like flowers. So they will get into the flowers first because they like to feed on the pollen. And so if you look at the flowers on the petals, if you've got coloured petals, what you'll see is some whitish areas. That's where they've sucked out the pigment. And then you might also see some darker spots. So what they do is they feed on the pigmented, let's say it's a purple petal, they'd feed on the purple pigment in the petal cells. And then they produce these after a while, they produce a kind of fecal droplet, which has got a lot of the pigment in it. And when that dries out, it dries a kind of darker colour than the pigment of the flower. So on a purple flower, you'd see these dark purple spots, and you'd also see these little white patches where they've fed. And so you can get very few thrips in a flower can cause quite visually obvious damage to the flowers. So those are thrips that prefer to go into the flowers. But when they're on the leaves, I think you'd generally look, they can retreat into leaf buds or into flower buds. So that would be perhaps a place to look. But they will also feed on the undersides of leaves. So if you turn the leaf over and look for little patches of silvering or where the little insects sort of near the veins often, that's one way to spot them. But as you say, with the hand lens, you can detect them at an earlier stage. So if you've got a houseplant that's got flowers, look in the flowers. Thrips, adults, you'll see the adults are much more obvious than the larvae. So it'll be the adults you'd probably see in the flowers. Whereas on the underside of the leaves, it's probably yellowish larvae. So you'd be looking for little yellowish thrips underneath the leaves. But in the flowers, the adults are usually sort of light brown to dark brown to black, depending on the species. And they can look rather obvious within a flower. So if you can hold the flower close to your eye with a hand lens and look inside, you would see them probably in amongst the stamens because they'd feed on the pollen.
Yeah, it's a horrible shock when you find some thrips, but it is good to know what you're looking for. I found them on my a very sort of neon green aroid, Thaumatophyllum aroid, and it was quite. Actually, the colour didn't really help me because the very sort of neon green leaves hid the thrips quite well until they got to the adult stage when they turned darker, and then I was able. That's when I spotted them. So, yeah, as ever with pests, sort of eternal vigilance. Going back to the colour of the traps. The thrips traps seem to be blue, but presumably they'll be attracted by yellow traps as well?
Yes, you'll still catch them pretty well effectively on yellow traps. It's a strange thing that these blue traps seem to be particularly effective in the summer, in bright light, I think, more often. There are certain shades of blue that are particularly effective for trapping certain species of thrips. So they're often used by commercial growers because they're more selective. You don't get so many of the other species. You won't get your bees or your pollinators on a blue trap. Strange thing is that we don't really understand why that shade of blue should be particularly attractive to thrips. It's not just one species, it's several species that seem to quite like blue traps. And it's not the same as the blue of a sky. They're not sort of mistaking it for the sky and flying towards it, because the traps are blue without the UV. So they would appear a different colour to an insect. The sky is blue when the clouds aren't there. It's blue with UV. So it would look very different because insects can see the UV component. So it's a bit strange. Western flower thrips, which is probably the main thrips pest of indoor plants, and glass houses where they're growing houseplants, Western flower thrips does go for this blue, but Western flower thrips can feed on just about anything. It's a very prolificous, it feeds on many different plants, and yet it seems to have this preference for a certain shade of blue. But if you use yellow traps, you're still going to catch them. They're still highly attractive to thrips anyway, just the yellow ones.
Okay, that makes sense. Well, I've got both. I've got yellow traps and blue traps. I mean, my main issue is trying to avoid accidentally sticking them to the plant, but yes. Just getting the right angle and position to catch the insects without getting the plant involved is. I mean, I guess when you're in a nursery setting, you can have them hanging just above plants and things, rather than my sort of Heath Robinson methods of putting them around the plants.
The best position is sort of about a hand's width above the top of the plant. Which means, of course, as the plant grows, if it's a fast growing in a glass house, you've got these pepper plants, say, coming up, you'd have to keep moving them up to keep them out of the way of the top of the plant. But more of the problem is, say, in something like a strawberry crop, there are people coming along picking the strawberries, and then they tend to get their hair stuck in them, which is
yes,
not
I can
so nice.
imagine that. We'll be back to talk more about thrips with Professor Kirk shortly, but now some housekeeping. Thank you to Silver Devastation. You guys come up with the best names for your podcast reviews. Silver Devastation left a lovely review for On the Ledge on the UK Apple Podcasts, and Pat and Jessica became legends. That means they became Patreon subscribers to On the Ledge. And talking of Patreon, I've been sitting on my rug in my lounge, writing out lots of cards to my Patreon subscribers at the Legend and Superfan level. And it's been an absolute delight. It's been a bit of a cottage industry in my family, with my daughter and my husband helping to stick on labels and write out addresses, because some of your addresses didn't go through the database particularly well. Some of those special characters got rather mangled. So I've been writing out these cards, and it's reminded me of lots of lovely listeners who support the show, those who've been there since the very beginning, and some of you who've joined in the last few months. You're all wonderful, and it really got me in the back of the throat to think of all this wonderful support. So those cards will be going out in the next few weeks in time for the festive season. So if you're a Patreon subscriber and you've added your address for mail outs, then that'll be on its way. And I really appreciate, as ever, all your support. On to question of the week, which comes from Sarah and concerns cat versus Hoya linearis. This is one of those stories that cat owners sometimes dread. Some cats just seem to leave plants alone. Others just like to have a bit of a play. And it seems that way with Sarah's cat. And Sarah asks, If a Hoya loses its leaves, can a new leaf regrow to replace it? Or will that spot be bald forever? And Sarah says that the vines grew and became in reach of the feline in question. And obviously the cat decided that it looked like a good scratching post. Sarah asks, will those leaves grow back, or should I try to propagate those leafless nodes? What a great question. I mean, this is about Hoyas, and I know I do answer an inordinate number of Hoya questions, but this applies to so many other plants that it's quite a useful question. So when we're thinking about leaves, what have we got? Well, in the case of a Hoya vine, you've got that long stem, and along it there are the leaves which dangle down. So it's kind of hard to see what's going on actually in terms of where the leaves are attached to the stem. But you've got those leaves attached to the stem all the way along, and the plant is growing mainly from the end of that vine, the growing point, and that is called apical dominance. So the plant wants to grow out and along that vine. And in the case of Hoya linearis, obviously, it can get quite substantially long. I've cut mine so many times, but it just keeps on growing, and it's probably getting on for 6 foot long by now, I would think. So the good news is, Sarah, that your Hoya linearis will be absolutely fine, provided the cat doesn't keep shredding it. What happens when you cut the tip of that vine off is that you remove apical dominance, to use the phrase that from your botany classes. And that basically means that the message goes out to the side shoots, the axillary buds that are embryonic buds of leaves that sit in those nodes, the place where the leaf joins the stem. And the message is sent out to them, oh, we've lost our head, therefore you need to start growing. And this involves the hormone auxin. It's kind of I've just been reading some academic papers on auxin, actually. We don't really still understand how it fully works, which is true of so many things in life. But yeah, these complicated hormonal messages are sent to these side shoots, these axillary buds, get growing. And so these will grow out from that node and start so that the plant can put on new growth even after that growth tip has been removed. So I think in the case of your plant, it depends if the very end has been cut off or knocked off by the cat, or if it's just done damage along the leaf. I suspect, Hoyas are wonderful because what Hoyas do is they have these very, very, really productive nodes that when there is damage, they will just naturally start putting out new growth and branching by producing axillary buds from those nodes and creating new stems. So I would imagine that your Hoya will start to bulk up in that area quite quickly. What it won't do is grow brand new leaves from exactly the same point where the old ones came out. Now, in the case of Hoya linearis, that doesn't really matter because the leaves are so numerous and they hang together so well that actually it won't take long for the plant to kind of camouflage that damage quite quickly. If you had a Hoya which had really huge leaves in individual ones, then you would have a different kind of story in that those big leaves would be missing and you would get new growth side shoots coming from that node, but you wouldn't necessarily have quite the same look, if you see what I mean. So, this is what happens to plants in the wild all the time. Obviously, they're getting this kind of damage, and so they have ways of dealing with it. It's fascinating to know the different ways that plants can respond to damage. For example, lots of the epiphytic plants that put out aerial roots, they will put out aerial roots that go into a nearby tree to anchor themselves, but they'll also put out these feeding roots, and those feeding roots are really important. So in the case of something like Monstera deliciosa, the plant can actually survive the stem at the base where it's growing in the soil being totally destroyed, provided it's got a good number of feeding roots. The rest of the plant will just keep on growing because the plant has so well anchored itself and provided itself with a root system separate from the original growth point of the plant. So plants are really clever at this stuff. I think your Hoya linearis will be fine. Difficult to know without actually seeing a picture of the plant. But what I would probably do is cut off that long stem. and propagate it, because that way you're going to get, you could, if it's a long piece of stem, you could cut it into several cuttings and then you could put them back in the top of the pot. You'll end up with a more full plant, and the plant will naturally, from the point where it's cut, produce new growth that will be beautifully replete with leaves. So take that cutting off, and there's a number of ways that you can propagate Linearis. I think when I did it, most recently I put it in a clear plastic bag. I mean, it's difficult with, normally I would say, oh, we'll trim to just below a node, but with Linearis, and with a lot of Hoyas actually, they tend to just produce a heck load of roots from all over the stem, because that's the way they grow. Put them in the bag with a tiny bit of moisture in there. They'll grow roots, and then you can chop off any roots that are too high up, and any roots that are able to go into a well-drained potting mix can go into the well-drained potting mix once they reach sort of 5 centimetres or so long. And that way you'll propagate more Hoya linearis. And if you don't need to put it back into your existing plant to bush it out, then you can always give some away to somebody else, which is a lovely thing to do. I hope that is helpful, Sarah, and that your cat find something else to play with. Perhaps he or she needs a new toy. I know it's hard to keep track of cats all day. I mean, my dog just sleeps on the sofa and he never touches my plants. So I tend to forget quite how much you need to pay attention to what cats are doing. But I'm sure your cat is adorable, and the damage to your Hoya linearis is not going to be too bad. If you've got a question for On The Ledge Podcast, drop a line to ontheledgepodcast@gmail.com. And remember, I'm after your festive questions, so have a think about that. What poinsettia horrors would you like to set loose on me? Have a think and do get in touch. Now back to my interview with Professor William Kirk on thrips, and we're going to talk about how to actually control the little blighters. What are the biological controls that work on thrips?
There's a range of options. If you're looking at biological control, you're usually talking about just managing the pest at a very low level, keeping it under control. So it's an ongoing process. It's not just a one-off. It's unless you absolutely bombard the thing with biocontrol agents, you might possibly be able to eliminate the thrips. But usually when growers are doing this, they're just managing it at a low level. So some of the options, possibly one of the best options is to use predatory mites. These used to be known for a long time as Amblysseus, but the newer name is Neoceulus. So you might see them advertised as both. And there are several different species. Neoceulus cucumeris, it's obviously something to do with cucumber, but can be used to biocontrol thrips. That species is good at slightly lower temperatures. So if you had plants in a cooler conservatory or greenhouse, that might be appropriate. And there's another one called Neoceulus svirskii, starting with SW, svirskii. That's better at warmer temperatures. So for indoor, where you've got, say, more than 20 degrees C, that's pretty good. These predatory mites, obviously being mites, they're pretty small. They can't actually kill and feed on the adults, but they can kill and feed on the small larvae. So you don't get an instant effect. What you do with these predatory mites is have a little sachet, so it's releasing them, and that would keep it sort of at a low level. But if you've got a great big infestation in the first place, that's not going to work very well, because they can keep something at a low level, but they can't really bring it down from a high level. So those predatory mites, and in fact, they're widely used now in glasshouses, say in the UK, for biological control without having to depend on insecticides. Bear in mind, of course, when you're using biocontrol, they're usually not at all compatible with any kind of insecticides. Even things like insecticidal soaps can still be harmful to predatory mites. So you have to choose what strategy you're going to go down. Are you going to go for a zero tolerance where you use insecticides and you try to get rid of all pests completely? Or are you going to sort of manage them and keep them at a low level? In which case you could use the mites. There are also predatory bugs. The common name is minute pirate bugs, which is a rather fancy name. They again need warmth. So again, in a warm place where you've got houseplants, they might be all right. Their name is Orius, Orius. The downside of that is that they're a little bit bigger than the thrips, perhaps, 3-4 millimeters. And if they land on you and they think you're a plant, they will probe with their mouth parts, and that can be a bit painful. Give a sort of bit like a mosquito bite. So that might not be the best approach for house plants if you're sort of living in amongst them, but they're very effective as predators because they feed on both the larvae and the adults. And that's something that commercial growers are using, particularly in warm glass houses. Another possibility, nematodes. These come as a sort of, you make up a kind of solution and you spray or water over the foliage. And there's a particular nematode called Steinonema feltii, and you find this under trade names such as Nemesis or Entonem, various possibilities. And this parasitizes the thrips. So it's sort of the little tiny nematodes, which are too small to see. When the thrips is in contact with them, the nematode will work its way into the body of the thrips and multiply within it and kill it. So they can be quite effective as nematodes. There are entomopathogenic fungi. That's fungi that breed in and kill insects. So there's a well-known fungus called Boveria, which can sold under various trade names, but that will kill thrips and probably also whiteflies at the same time. Again, with all these biologicals, you have to be careful how you look after them. They don't last forever in a fridge, for example. You've got to have them fresh and active and use them fairly quickly.
Yeah, that is definitely key, isn't it? I think sometimes people don't read the instructions properly and then realise that they've waited too long to apply them. And given that they're not super cheap, it's definitely worth checking out the instructions. Is that the same nematode that's used for fungus gnat larvae?
I think it probably is. Yes,
name rings a bell.
Steinonema feltii. Yes, I think it's not specific to thrips.
Oh, that's interesting. I mean, that would be, I guess that's a good one to choose if you've got both problems at the same time.
Yes.
You might be able to tackle both. As you say, it's not a one-off solution, is it? Is there a particular time of year? Oh, how many times a year would you say you need to sort of blast your houseplants if you've got an ongoing thrips problem, just to keep it at a acceptably low level? Is there any sort of regime that you would suggest?
Yeah, well, if they're indoor houseplants and you're keeping a fairly stable temperature, it doesn't really matter very much. Aureus bugs certainly need warm conditions. So if your conditions get cooler in the winter, both Aureus needs warm temperatures and Neosulus sphaersky need warm temperatures. So if you're warm all year round, then it doesn't really matter very much. But if you're, using a cool conservatory, then you'd be trying these things in the summer. But of course, with biocontrol, generally what you're trying to do is you have to keep using them. You're not eliminating the thrips usually, unless you really bombard them. I suppose that might be possible, but usually it's quite difficult because thrips can come back in again. They hide away. If you're bringing new plants in and out, even if you quarantine them for a couple of weeks, you may still find things appearing. So it's quite difficult.
And presumably, if you're talking about chemical control, you'd be wanting something systemic, a systemic insecticide. Does that help in terms of dealing with the overall problem? If you want to go down that route, obviously, bearing in mind that then biological controls are not an option.
Yes, well, systemic is best because the thrips are actually feeding on the plant tissue inside the plant. So they're not, although they're in contact with the surface, if you want to get it to the insect very effectively, suppose the larvae or adults are deep within a flower bud, something that's just sprayed and has a residual contact insecticide isn't necessarily going to get to where the thrips are. But if it's systemic, of course, then it'll get through the system of the plant into the leaf buds or the flower buds, and then the thrips will end up feeding on that material. So that's more effective. But it's getting much harder to find for private use. It's getting harder to find the appropriate insecticides. So many, certainly in Europe, are being withdrawn on safety or environmental grounds. And there's also a problem, of course, that of resistance is growing. So spinosad was quite widely used on various crops in the UK, but the resistance has been spreading quite fast. And sometimes, for example, growers of strawberries that were reliant on spinosad find they're spraying it and nothing much is happening. The thrips are taking off. So you've got a resistance problem as well, and a limited number of choices.
I guess that's really where the biological controls do come in that, they're going to just go on working and resistance is not a problem. I mean, I guess unless the thrips figure out a way of not being eaten, I don't know how quickly they can evolve. Cultural controls obviously are, usually I'd be recommending, lots of cultural controls for dealing with pests. Is there much you can do other than just keeping your plant healthy and quarantining new arrivals to try to prevent your plant from getting a bad infestation in the first place?
Well, quarantine is important because I think the usual way they'll come onto houseplants is on a plant you've bought in from a nursery or garden centre. And of course, I sometimes buy orchids from, we buy orchids in from garden centres, and sometimes you can find I haven't seen many thrips on them, but certainly they can be pretty infested with pests. So they're not immune, even if they look a bit clean. Look closely and quarantine them for a few weeks. We get pot chrysanthemums. We actually buy in a lot of these because we actually keep thrips as part of our research. So we're keeping Sainsbury's going by buying 3 or 4 pot plants of pot mums every week, and then we feed them to our thrips. But sometimes we notice the odd thrips is coming in on the plants. So they come in and they're almost impossible to spot. So the quarantine is important. Of course, they like healthy plants because juicy leaves, healthy with flowering well, lots of pollen, those are all good for the thrips. So culturally, keep your plants sensibly watered. If you stress them, that's going to weaken their resistance to thrips. But another approach, which I haven't seen used in house plants, but might be something people could try out, and is something that is done with commercial crops sometimes, is because the thrips drop to the ground or drop onto the soil surface, some people put some kind of special mulch down on the surface, which might be something, a reflective powder or something that's has some kind of insecticidal effect, coating the soil surface.
Yeah, that's an interesting one. I have heard of people who say that when they do get a thrips infestation, that the first thing they do is literally wash off all the soil off the plant and just get it back to sort of zero in terms of substrate, wash everything off and repot in a fresh substrate just to ensure that any pupa that were in the soil have been removed. I mean, of course, I suppose that's a bit of a waste of time because there could be lots of eggs sitting in the leaves waiting to start the cycle again. But I can understand why people do that as a first measure. I have heard of people also who will take all the soil off and cut all the leaves off on plants that can regenerate from their rhizomes or whatever as a kind of scorched earth approach, which I guess, can work.
It's kind of dramatic, but I'm not sure you need to go that far. When you've got an infestation, the larvae will drop to the soil, but we also find that if the soil dries out a little bit, then there's quite a big crack between the pot and the soil down the edge. Or it doesn't even have to be big, it's just a very small crack. That's where the larvae seem to walk to the edge of the soil and get down there. So if you pull the whole plant out with its root ball and the soil, you can often find the pupae down there. So it's not just the surface of the soil, but to sort of change the pot or wash the pot. In fact, actually rinsing the whole plant with water can wash off quite a few thrips. So it's not going to get rid of all of them, but it's certainly going to set it back. So in crops that are grown outdoors, when there's been rain, that knocks the thrips back. And sometimes when people are doing experiments, they have a control. Compared with some insecticide or some treatment, the control might be spraying with water. And it's surprising how often spraying with water actually knocks the thrips back quite a bit.
Oh, that's that's a cheap solution, isn't it? I mean, it's just your time, I suppose, if you've got a lot of plants to wash. But I think washing down your plants is good for any number of reasons. And I guess among them is control of thrips. Well, I mean, as you say, it seems like you need a sort of a multi-pronged approach to this particular pest. Is there anything else you can do that we haven't mentioned in terms of controls of any kind, or have we covered the main bases?
I think we've covered the main bases. I think if you've got sticky traps, then you're going to possibly with luck, you might mop up early arrivals. So certainly if you're quarantining your pests, have some sticky traps all around them, because a plant could come in with just one female thrips on it, and that would be enough to start an infestation. So if you just happen to catch that one, that would stop the infestation. In fact, most species of thrips have got males and females, but in fact, it's a strange feature of the thrips biology, but a female thrips that's not fertilized, when it lays eggs, they become males. And if it fertilizes those eggs, they become females. So we've got the situation where a larva could arrive on a plant. It emerges as an adult female. It doesn't have to mate. It can then start laying eggs, which become males. And then that female can mate with its own sons and be fertilized and then produce females. So one larva is enough to start an infestation. So it it shows how rapidly yes.
No wonder they're so successful. Wow, that's quite some reproduction regime.
Yes.
That's amazing. And I mean, you've spent 40 years studying these thrips. I mean, is there anything else that we kind of need to know? Any more fascinating thrips facts to add in?
Well, yes. I suppose what I've learned over 40 years, I haven't cracked the problem yet. I need another 40 years. But one thing is that even though they're very small, their biology is no less fascinating than larger insects or even larger animals. So you've got this various curious things about their biology. I mentioned this thing about unfertilized eggs becoming males. Even the common species have some fascinating biology. So, for example, the western flower thrips, which is probably the main pest of houseplants, that has several different pheromones it produces for communication. It has alarm pheromones that the larvae communicate to each other to warn them of danger. Males produce an aggregation pheromone that attracts the females. The males also apply to the females an anti-aphrodisiac pheromone, so that when they've mated, it deters other males from mating with them. So you've got all these fascinating areas of their biology. And in fact, some species in Australia, not ones that are pests on houseplants, are social, like bees and wasps. So you have a large colony of these thrips, and then you even have soldier thrips that fight to defend the colony. So we've got some fascinating biology going on.
It's amazing to think all this is happening on our plant leaves and in the wider world. I mean, I have increased respect for thrips, but also you've increased my fear level, because I just think the idea of one tiny larva coming in and an outbreak. I have to say, the plant that I had the worst outbreak on has been exiled to the garden, and I need to make a decision in the next couple of days as to whether I'm going to bring it in for winter or whether it's going to go on the compost heap. So I'm not sure whether it's worth it or not, but I'm sure there are some more thrips kicking around. They do seem to be attracted to particular plants in my experience. And, you know, I've had other plants standing right next to the one that had thrips that didn't get any at all. So I imagine there's a lot going on in terms of what their preferred food sources are, but and lots more to learn. But it's been really fascinating to talk to you, Professor Kirk. Thank you so much for joining me, and I think we'll all be checking our plants for thrips now.
Thank you. My pleasure.
Thanks so much to my guest, Professor William Kirk, and as I always say, please go and check out the show notes, because I beaver away and put lots of information into there which will back up what you've listened to in this episode, and is a great resource for dealing with thrips. So do go and have a look at that. And in the meantime, wishing you a fantastically planty and thrips-free week. That's hard to say, thrips-free. I will speak to you in exactly 7 days. Bye! The music you heard in this week's show was Roll Jordan Roll by the Joy Drops, The Road We Used to Travel When We Were Young by Kamiku, and Insectify by Kid Nasty. All tracks are licensed under Creative Commons. Visit the show notes for details.